Hello space lovers. How well do you know our solar system? You guessed the planet. It is more than 2 times more massive than all the other planets combined, and is covered in amazing vortices and hairs. In fact, these are clouds of cold ammonia and water floating in an atmosphere of hydrogen and helium. Still haven't figured it out? Then look at this. This famous Great Red Spot is a giant storm, larger than our planet, and it has been raging for hundreds of years. You are right, this cloud world is Jupiter. And the main question is the planet our enemy or friend? NASA's orbiter called Juno is now exploring this gas giant, transmitting to us a lot of useful data. In Jupiter is so large that 11 Earth planets could fit across its equator. If our planet were the size of a grape, Jupiter would be a basketball. The gas giant is the 5th planet from the Sun. It orbits at a distance of about 779 million kilometers. And although for us Earthlings our blue-green world seems to be the most important among all the other planets, we live in the solar system of Jupiter. After all, it accounts for 75% of the mass of all the planets in our star system. It is also 318 times more massive than the Earth, and Jupiter gets everything it wants. Jupiter wants to scatter things, and there is no problem throughout the solar system. After all, it's not for nothing that this gas giant has enormous gravity. It takes material from the asteroid belt, preventing the poor space rocks from forming into something larger than Ceres, the only dwarf planet in the inner solar system. Jupiter is hungry. It devours comets, asteroids, etc. Jupiter is bored. It throws everything it manages to capture onto a long trajectory. During its life, this is about 4.5 billion years. This gas giant has caused a lot of destruction, but what's the matter? Some scientists believe that we may owe our existence and the existence of our planet to the protective gravity of Jupiter. Strange as it may sound, the planet is vacuuming up the solar system by greedily swallowing dangerous space objects. Other astronomers do not agree with this theory. They claim that Jupiter is a bully that disturbs peaceful and safe comets and sends them to unexpected places. Some of the most dangerous objects in our solar system are long-period comets. These are huge pieces of ice and rock flying from the depths of Earth, which is located far beyond Pluto. Which lies far beyond Pluto. Some of them end up in the inner solar system, where they zip past the Sun. There is a possibility that the most devastating extinction event on Earth was caused by a long-period comet. As such comets make their way through the solar system, they likely interact with Jupiter's gravity. The gas giant pushes the idol this way and that, devouring some of them like tasty ice hamburgers. But does Jupiter push such comets out of their dangerous orbits to prevent them from crashing into the Earth, or does the gas giant change the trajectories of comets that would otherwise fly past the Earth? No one there knows. Astronomers sometimes call Jupiter a failed star. The gas giant does contain a lot of helium and hydrogen, the substance from which stars are mainly made, but the mass of the planet is not enough for a thermonuclear reaction to begin in its core, which is how stars generate energy. They fuse hydrogen atoms together under intense pressure and heat, resulting in the formation of helium. They also release light and heat in the process. Jupiter would only be able to undergo a nuclear reaction and become a star if it were 75 times more massive. It is paradoxical today, but if Jupiter became even more massive, it would become smaller. The additional mass would make the planet denser, and this would lead to the fact that the gas giant would begin to shrink. Astronomers are almost certain that if Jupiter's mass were 4 times its current mass, it would remain the same size. Jupiter has between 80 and 905 moons. One of the most interesting is Europe. Imagine a motionless frozen world. It is ancient, about 4.5 billion years old. It is almost not heated by the rays of the sun and is covered with a thick layer of ice. This world is smaller than our moon, but a little larger than Pluto. This is what Europa looks like, the 6th satellite of Jupiter and one of the largest satellites of the solar system. And the most intriguing thing about this distant place is that there may be life there. Astronomers consider Europe one of the most promising places in the solar system for searching for new forms of life. This is because there is a huge ocean of salt water, with a depth of 64 to 160 kilometers. It is hidden under a thick layer of 16 to 32 kilometers. But it is still potentially suitable for life. Astronomers say that thin sections of water burst out of cracks in the ice shell and throw the contents of the oceans into space. For a long time, scientists have wondered about the origin of X-ray auroras on Jupiter. Scientists have wondered about the origin of X-ray auroras on Jupiter, what causes them. A 40-year-old mystery appears to have been solved. X-ray auroras, caused by electrically charged particles called backgrounds, crash into the gas giant's atmosphere. And the result is that astronomers could not understand how these ions get into the atmosphere. But recently they saw how ions roam through Jupiter's magnetic field all the way to the planet's atmosphere. Astronomers obtained this data thanks to the Juno spacecraft and the XM Newton telescope located in orbit of the Earth. On our home planet, auroras are visible only in the belt around the magnetic poles between 65 and 80 degrees of latitude. Beyond the 80th parallel, they disappear, but the X-ray auroras of Jupiter are much more fickle. They regularly pulsate towards the poles from the main belt and can flare directly at the south and north poles. Scientists have found that this pulsation is caused by fluctuations in Jupiter's magnetic field. As the planet rotates, it pulls its magnetic field with it under the influence of particles from the solar wind. It contracts. This heats up particles caught in Jupiter's magnetic field, and they begin to move along the magnetic field lines, creating magnificent auroras. Another feature of Jupiter, its great red spot, is a huge storm raging in the southern hemisphere of the gas giant. Its upper parts rise more than 8 kilometers above the surrounding clouds. The width of this storm is more than 2 times the diameter of our planet at the edges of the storm. The wind speed reaches from 430 to 675 kilometers per hour, which is faster than the Earth's. Hot gas transfer planets are constantly in motion, rising, falling and swirling, just like on our planet. When cold and hot gases mix and merge with each other, on the other hand, they form giant circular vortices. Astronomers believe that one day several huge bores came together to form a large red spot, and now it continues to rage, constantly drawing in cold gases from below and hot gases from above. In addition, this monster absorbs other, smaller vortices. They make the spot even more powerful. Several theories try to explain the characteristic color of this storm. It ranges from whitish and pale salmon to orange and brick red. Some scientists believe the answer lies below the Great Red Spot, closer to the planet's surface. The colorless layer of ammonium hydrosulfide may have reacted with cosmic rays or ultraviolet radiation coming from the sun. This somehow gives the stain its beautiful red color. But for now, this is just a theory. Astronomers have been observing the Great Red Spot since the 1830s. The first storm was noticed in 1665 and described as a permanent spot. In general, the storm is almost 400 years old. Strange, but at the beginning of the 21st century it decreased in size. In 2019, it began to delaminate at the edges. Small fragments break off and disappear. If this process continues, by 2040 the Great Red Spot could become round or even disappear. This is the story of our Jupiter. If you liked the video, be sure to subscribe and like this. You will support our channel. Thank you for your attention.